All right, we are back into our science. I'm going to be busting through some of this pretty quickly, specifically this last little section here on efficiency. I would normally have assigned some questions out of this, but we've already talked about specifically we've already talked about some of this in grade 7, how to make sure that what you're using is more efficient. I made you guys in grade 7 make a ice cube cooler so that we could make sure that the ice cube didn't melt. I hope that stuff is all still kind of trapped away in your head somewhere. Most of this is just really simple to go through. How do we make sure that things aren't wasting energy? And so like the section on lubrication and reducing friction and things like that all make pretty good sense when it comes to efficiency. I hope that it's pretty common sense stuff. So I'm just kind of in order to actually have enough time to get through everything else that I feel like I need to get through to make sure you're ready for next year. I'm skipping over this in some level. It's not all that hard. Again, if you want to go through some of these questions and take a look at them and make sure that you're able to do them, it involves mostly the stuff we've already learned in this unit, and it should not be overly difficult to get through if you want to try them out. Again, I'm thinking it's not the end of the world if you don't do those, because they are non-essential when it comes to me making sure that you have the right amount of information. This last section here is really interesting. How do we get the electricity that we use? And so if you look over on the side over here, what are different sources of energy and different energy options? And so there's going to be a lot of YouTube videos, and I'm going to put up a video from Bill Nye, not one of the usual kind of lame Nye, the juvenile ones. I'm going to put up an Eyes of Nye video, which is really, really good. It'll take up 2 class blocks, 2 20-minute blocks to get through that. So this is a really, really interesting section. We'll talk about the benefits of different energy sources. Like right now, most of the electricity that we use in Alberta comes from coal-fired generation. Are there better ways for us to get electricity? Are there other alternatives when it comes to electricity that we can use to generate or to maybe just be more efficient with the electricity that we generate already? So there's lots of different ways that we can do this. So this first section is kind of going through the basic process of electricity generation. So most of the stuff that we do basically works in this exact same manner. And actually, like this is a coal generation plant. This coal generation plant is the exact same thing, just with a different fuel source as a nuclear generation plant. Right now we're talking about getting nitrogen to China and to Asia, so that we can both help bolster the economy as well as reduce greenhouse gas emissions, because burning natural gas is actually a fairly efficient way to do this, way more efficient than coal. But this whole apparatus here where we create heat, and that heat boils water, the water turns into steam, and as it goes through this whole cycle, it spins a turbine. That turbine is attached to a generator. The generator, again, like we learned about in the past, is a series of magnets and electrical wires that, as they move through there, generate electricity by pushing electrons through. This whole process here, when we're using heat to generate electricity, and actually even like a nuclear power plant, is very, very similar to this. But instead of having a fire down here where we burn some form of fossil fuel, a nuclear power plant instead has radioactive isotopes that we bombard. And I'll put a really good video up for that again from the Eyes of Nye. So this whole thing operates pretty much the same way. This cooling tower cools the heated water, the steam, and turns it back into water so it can be reused and boiled over and over and over again to spin this turbine, to spin the generator to generate electricity that you use to watch this video right now. So all of these things basically work the exact same way. Again, I'll put up a really good video on nuclear fission what I would normally do is have you guys watch some form of video on different ways to generate electricity, and I'll put those up on the Google Classroom as well. In this section, other alternatives that we can use, not very far from the school, we have a biomass station or cogeneration station. So basically, there's two different ways that we can use the waste that goes on. We can either burn it. So Canfor has chip piles that they use. They can either use it as biomass and let the decomposition of those chips generate fuel that we can use, or heat that we can use to spin a turbine to do generation, or we can also do the station over here at Canfor as a cogeneration station, and they actually produce almost all of the electricity that they need to run the whole Canfor factory, which is, in all honesty, pretty amazing. I have an uncle not too far from here that drilled I just want to say a hole, but he drilled a well basically down deep into the ground, and he collects geothermal heat, and he doesn't have to pay for any heating of his house anymore. It both provides air conditioning in the summer as well as heating in the winter, and it's a really cool setup. I'll be honest, it was like 80 grand to do that, and he wouldn't, like, he's not that young. He won't pay $80,000 for the heating of his house for the rest of his life. So is it automatically that beneficial? Geothermal heating around here isn't, but a country like Iceland, which again, I'll put another video up for you guys. Iceland is right on a fault line and has tons of geothermal heat. They have entire lagoons where you can go and kind of hang out in them, and they are natural hot tubs because they're just heated by a geothermal spring, kind of like what you can see over here. But they don't pay for any heating or any electricity for their entire country because they have an abundance of geothermal heat. And geothermal, geo meaning earth, thermal meaning heat. And so they basically have collection stations where they collect steam that is coming out of those cracks and fissures around the fault lines and produce just a ton of heat and steam, and they use that to generate almost all the electricity. I'll put a fun video up of them baking bread with it too. So all sorts of cool things. Other alternatives, which again, we don't do as much. There are ways to generate electricity using water. So a hydroelectric dam, like lots of you guys have been to the Bennett Dam, it basically uses gravitational potential energy of the water. So the water is stored up behind the dam. The gravity of the water going through this channel will spin the turbine. The turbine, as it spins a generator and goes to the transformer to send electricity out. So hydroelectric is, generally speaking, very, very clean. But there is a cost to that too, because in order to have the gravitational potential energy for the water to do the work that it needs to do, you have to flood crazy amounts backstream to do that. I'll put up a video of the Three Gorges Dam in China, which provides electricity for something like 4 million people. But again, they had to displace millions of people along the river that they backed up. And right now they're actually, one of the things I've seen recently was that they're dealing with earthquakes around the walls of those rivers because the banks are experiencing more pressure than they're used to and are being pushed out by the water that's kind of locked up behind them. So you don't get something for nothing, I guess is what I'm trying to say. So other sources of energy, again, I will put up a ton of videos for this, but there's tidal energy, so the movement of water in and out. We've tried that in some of our more substantial tidal areas. That works. There's wind energy. Wind energy is quite popular with a decent amount of the population. Again, perks and pitfalls with it. Apparently they are very loud. I've never been near too many wind farms. And the amount of energy that